Hi, Chris Kuzmal here. Today we're working on binary search trees and we are interested in implementing the successor method and the minimum method to ultimately help us implement the delete method, which currently is incorrect because and is detected by one of our test cases right here. And so to get to correcting that test case, we created two additional test cases. One which is going to test the successor. It's just the first of several test cases for successor we probably ultimately want to create, and one that will test the minimum. Um, and all we do is we create a binary search tree. We add a node with a key 3 and another node with a key 4, and that's what happens on lines 126 through 129 in the case of the test successor 1 method. And the exact same code happens for test minimum 1. This suggests that there's an opportunity still for some encapsulation, maybe some create default test tree, something like that might be the right thing to do. Uh, and then what's the successor in our default minimal test tree? It's it should be the successor for node FE should be node SE because after all, it's the only other node and the value of the key in that other node is larger. So that's going to make it its successor. And the minimum, meanwhile, the minimum will be node FE because FE's key is 3. So that's the situation. Um, we need to implement minimum. So minimum is not so hard. So minimum is a method within the node class. We could have put it in the tree class perhaps, but we put it in the node class. Oops, that's the node, that is node class. We want node.java. And what we're interested in is the minimum. Okay. So it's going to be a node. Uh, and what we're going to do is we're going to say while my left child get L child is not null, I'm going to do something. If my left child is null, then my node, this node, is the correct answer. So I'm going to return this. All right. And actually, what I want is a node that is a return value, which I'm going to start off as being this. I accidentally deleted something there, and then I had to put it back in. And then we're going to put retval here instead of this. And so this is all lovely, except that now in this loop, while my left child is not null, I want to make my retval equal to that left child. Okay. And that's fine, but really what I want to do is I want to say, while retval dot get child, which at first will be the same as this dot get child, which is the same as get child, but as we iterate along, we'll want to continue to update that left child. So I think that that's the correct code for finding the minimum. How do I know? Well, I can run my test case, except of course, I also need to have my successor code, but I'm going to be lazy about my successor code. I'm going to take my minimum code and I'm going to copy it. I'm going to rename it successor. The successor will incorrectly answer the minimum. And now when I run, oh, well, I don't run I have to actually invoke those test cases. So I'll have to do that next video, find out what happens.